this video, we will cover how to change the index or concentrated ounces to obtain an appropriate percentage of aldehyde in the tank. For purposes of simplicity and learning, for this equation we will give you just what you need to know for the information to plug into the formula. We use 64 ounces of an 18 index arterial, 8 ounces of a 21.5 index arterial, 16 ounces of a 32 index arterial, and the total volume in our tank is 384 ounces, or 3 gallons. For this equation, this is all the information that we need. But when given the problem, or given a word problem, you're oftentimes going to encounter more information. That information includes the supplemental chemicals, or the amount of water. This solution includes 4 ounces of one supplemental, 8 ounces of another supplemental, and 4 ounces of the last supplemental. For the first solution, we're just going to keep this simple. Using the same amount of arterial that you see on the screen, so 64, 8, and 16, adding them together, how much of an index do we need in order to obtain a 2% solution? At this point, pause the video. When we return, we'll give you the answer and how to work this all out. The answer is 8.727272. When rounded up, that becomes 8.73 index is the best index to utilize when using the same amount of ounces of arterial chemical in our tank. To solve this problem, we're going to first add together the 3 arterial chemical amounts that we have. So 64, 8, and 16, which equals 88 total ounces of arterial chemical in our tank. Next, we will plug in the 88 ounces of arterial into our standard embalming formula. So since we're solving for the index, that's the part that we're going to leave as a letter. So I times 88 equals 2 times 384, our total volume in the tank. And since we know our percentage, we're also able to plug that in. Next, we'll start by solving for the easiest parts of the equation to mathematically put together. And that includes multiplying the total volume by the percentage of 2, which gives us the right side of the equation as 768. Now all we have to solve for is the left side of the equation. To isolate the index, we're going to divide the right side of the equation by the numbers on the left side of the equation. When we divide 768 by 88, we get 8.727272, which we can round to 8.73. For our next equation, I've run into a dilemma. I do not have a chemical in my cabinet that is close to 8.73 index. So we're going to need to find the next best chemical. And in my cabinet, I have a 12 index chemical. But how many ounces of that chemical should I use to get a 2% solution? I still want 384 ounces as my total volume. At this point, we will pause the video and give you some time to work out this equation. When you return, we'll give you the answer and the solution. After working out the math, we find that we need 64 ounces of a 12 index chemical in order to get a 2% solution with a 384 ounces of total volume. To solve this equation, we're going to plug in what we know. So we're going to plug in our 12 index, because we know that. We don't know what our concentrated ounces are, because that's what we're solving for. So we're going to leave that as CO. Then our right side of the equation, we know we want a 2% solution, and we know that we have 384 ounces of a total volume. Next, we'll solve for the parts of the equation that are easy to solve for. In this case, we can multiply the 2 by the 384 to solve for the right side of the equation. This gives us an answer of 768. Next, we'll cancel out 12 from the left side of the equation, our index, and divide it by 768 on the right side to solve for the concentrated ounces. This gives us a concentrated ounces of 64. So we're going to use 64 ounces of a 12 index chemical to reach a total volume of 384 after adding our supplemental chemicals in our water. And that's going to give us a 2% solution in the tank. Now we're going to make the equation a little bit more complicated. How do I get a 2% solution by changing the concentrated ounces for only one of the chemicals? I've chosen for you that it's going to be the 18 index arterial. So keeping the rest of the equation the same, getting a 2% solution, how do I get that 2% solution? By changing the concentrated ounces on this chemical. Pause the video, work out the solution, and when we return, we'll give you the answer and how we worked this out. The answer is 4.66 concentrated ounces. We'll start by filling out the equation that we're very familiar with, plugging in what we know, and using alphabet letters for what we don't know and what we want to solve for. So in this case, we're going to have 18 index times the concentrated ounces that we want to change, and we're going to add that to the next chemical, our 21.5 index chemical that we used 8 ounces of, add that to our 32 index chemical that we have 16 ounces of, and we're going to have our 2% solution by the total volume on the right side of the equation. Next, we can solve easily for the right side of the equation. So we know that 384 times 2 equals 768. We're also easily able to multiply together at least 2 of these chemicals. So we know that our 21.5 index chemical multiplied by the 8 ounces is 172. And our 32 index chemical, which we use 16 ounces of, is 512 when multiplied together. Next, we can add together at least 2 of these chemicals. We can't add together the third because we haven't solved for it yet. Now that we know our chemicals of 172 and 512 added together equals 684, we can clear that from the left side of the equation by subtracting it from the right side of the equation. So we're going to subtract 684 from 768. This provides us a value of 84. Now we still need to clear the left side of the equation. We're going to do this by dividing 18 from 84, which gives us a concentrated ounces of 4.66. I really hope that this video helped you. Please click the link in the lower right-hand corner to subscribe so you can get more practice problems as they're added.